Welcome to this SD-GCM version 2.1 tutorial. In this video, we will use the Distributions tab to identify candidate probability distributions and compare fitted curves for downscaled precipitation. The tab has two sections. Find Distributions ranks candidate models, while the lower panel creates CDF and PDF comparisons across selected stations and periods. First, select the station to analyze. Here, I choose Station 1. Because precipitation is being analyzed, I enable monthly data. Monthly aggregation can provide a more stable distribution and reduce the dominance of individual dry days. The series may be evaluated as all raw values, annual maxima for high extremes, or annual minima for low-value analysis. For this example, I return to raw monthly downscaled data and then select Check 12 distributions. SD-GCM fits the available candidate distributions and ranks them using the Anderson-Darling statistic. A lower value means a better relative fit to this dataset. Anderson-Darling gives extra weight to the distribution tails. This is valuable in hydroclimate analysis, where unusually dry or wet conditions may be more important than values near the center. The table also reports the Ks and chi-square statistics, their test details, the fitted distribution parameters, and notes describing any fitting problems. Now review the key columns. Rank orders candidate distributions, while distribution gives each model's name. The AD statistic and Ks statistic measure goodness of fit, where lower values generally indicate closer agreement. Fitted parameters reports the estimated coefficients and notes flags fitting errors or limitations. Rank 1 is only the best candidate tested. It does not prove statistical acceptance. Now open best fit chart. The empirical CDF is compared with the fitted Cauchy curve. Close agreement is desirable, especially in the tails, where climate extremes are represented. Switching to PDF and histogram shows how probability density is distributed across precipitation magnitudes. The bars represent the data, while the curve represents the selected theoretical distribution. Use the distribution list to examine alternatives. Here, I select Nakagami, the second-ranked candidate, and the chart updates immediately. Visual comparison matters because one statistic cannot describe every feature of the data. After reviewing results, close this window and return to the Distributions tab. The CDF and PDF section creates comparisons. A CDF gives the probability that precipitation is less than or equal to a value. A PDF shows how probability density is distributed, revealing peaks, spread, and tails. This panel can plot one station, several selected stations, or all available stations. I limit this example to Station 1. I also enable add observation, allowing the downscaled climate data to be compared directly with the station record. Next, define the observation and downscaled periods. Each period should contain enough valid values for reliable distribution fitting. Here, observations cover 1993 through 2012, and downscaled future data cover 2020 through 2035. Because precipitation can contain zeros, I enable remove values less than and enter 0.01, leaving positive values for fitting. Next, select gamma. Always choose a threshold appropriate to the data units and scientific objective. With CDF selected, click Draw CDF or PDF. The chart compares the fitted gamma curve, the empirical downscaled CDF, and the observed CDF. Closer curves indicate more similar cumulative precipitation behavior. Now select PDF and draw the plot again. The PDF emphasizes distribution shape rather than cumulative probability. Here, density is concentrated near smaller precipitation values, while the long tail represents larger but less frequent amounts. Use Save CDF or PDF data to export the values, or Save CDF or PDF graph to save the figure. This completes the Distributions tutorial in SD-GCM version 2.1. Thank you for watching. If you found this tutorial helpful, please like the video, subscribe to the AgriMetSoft channel, and turn on notifications for more climate data tutorials.